So now let's talk about using the call stack with two stack frames. And let me open so now we have a function call within a function call here. So we have a function calling a function. It works a little bit the same, but it's going to look a little different. And so we have g equals 1, then we define incr, takes a parameter p, a equals p plus g, returns a. And then we have define incr2, takes parameter p, a equals p plus g, b equals the value of incr a. So this actually will call this, return b. And then finally, we have down here the code that actually runs, because only these two lines run when we start. The definitions get loaded into memory, but they don't do anything until we call them. And so when Python runs this, first g equals 1 runs, and we get 1. Then we define the two methods, but we don't do anything. And then down here, we call incr2. When we call it incr2, we're going to create something on the stack. And so on the stack, we get a stack frame for incr2. And then we go inside here, and the first thing in incr2 is, well, there's a p. And p, what's the value of p? Well, this 3 gets copied into p. The argument 3 gets copied into the parameter p. And then we run the first line. So now we're going to get an A. Look up the value of P. Look in the current stack frame. We have the value of P. We get a 3. Look up the value of G. Well, G is not in the current stack frame. So we look in the globals. G is 1. Increment them together, add them together, we get 4. And then assign that to A in the current stack frame. And then we run line B. Well, we're going to get a B over here, but I don't know the value of B yet. We actually have a function call to incr. So that means we need a new stack frame. And this stack frame is the function incr. So now we're up here. And incr has a p. And notice it has the same p as the other one. And this p here is actually going to be the value of a, which was 4. So we call incr a with the value of 4. That 4 gets copied into that p right there. So now we have p in here twice. Notice that we have p in incr. We have p here and we have p here. We have an incr and we have an incr2 with 2 separate values. So we have 2 entries. And that happened because incr2 was called and p was set to 3. Then incr was called and p was set with 4. So now let's run the value, let's run incr. So the first thing in incr, a equals p plus g. Well, we look at the value of p. And so which p are we going to look up? We have 2. The answer is we look at the stack frame of the function that's currently executing. We're in the middle of incr right now. And so p is going to have a value of 4, not 3. It's going to be 4. Then we look up g. And we look in the current stack frame, and it's not there. And we look in the globals, and we find it. So we get 1. 4 plus 1 is 5. And so in incr, we have an a, the value of 5. And notice again, we now have two A's. We have an A in Inker at 5 and an A in Inker 2 at 4. And the local stack frame for Inker, we have A equals 5, and that's the one we're going to use when we return. It's going to say, what's the value of A? And you look in the local stack frame, which is Inker, and it's going to give me the 5. Not the 4 that's in Inker 2, we're going to return the 5. And so we look up that A, we get that 5, we execute the return statement. So return 5 is going to make this a 5. And then the stack frame for Inker is over. We finished that function. It gets deleted. Normally I would erase it, but I don't want to erase it because I want to leave it in the notes. But it's erased, it's gone, it doesn't exist anymore, it's deleted from memory. And Inker returned 5, and so B now gets the value of 5. And then we're going to return B, and B has a value of 5. So this is going to return 5, but as soon as return B happens, that stack frame also gets deleted. And then we're back at Z equals Inker 2. Inker 2 just returned 5, and so at the global, we're going to set Z equal to 5. And then the program ends. And so now we have G1 and Z5 as the only thing we can access. And so if we run this version, and we have the value of G is 1, and the value of Z, we get 5. But again, there's no A, no B, and no P. None of those exist. And so that's what happens when you run with a function within a function. You get these two stack frames. But we only access one stack frame at a time, and that's the current stack frame. So when we were in Inker, we had the bottom stack frame, and then that disappeared. We were back to Inker 2, which is the top stack frame. And so the reason we call them stack frames is when you call a function, you create a frame for it. And within that function, you call another function. You get another frame for it. And then you call a function within that function, you get another one. But notice every time we create a frame, we don't touch the original. So we have the first function, the second function, the third function. And then when the third function actually finishes, it gets erased. Then we go back to the second one, so we remove it. So when it returns or ends, and then when this second one returns or ends, it gets erased, and we're back in the first function. And then when that function ends, it gets erased. And so we have this concept of these stacks that get removed. And so you enter a function, you create a stack frame, and then when you return, you remove the latest stack frame that was created. And the organization that we create this thing here is called a stack. You keep adding things, you keep stacking them, and when you return the last one. That's why it's called a stack. And you can think of this more as, imagine you have books on your desk, and then you add another book on top of it. And then you add a third book on your desk. And then you add a fourth book on your desk. And you say, okay, I want this book here, but in order to get to that book here, I have to take off the other 3 books first. You can only get to the book on top. And in order to get to the book on the bottom, you have to remove the books on top. It's a similar concept to what a stack frame is, except the stack frame uses functions and is represented in a similar way. But this is what a stack frame is referring to, is this concept of, in fact, I think I'll leave the book example there. So think of it as a stack of books, except we're using a stack of function calls repeatedly. Let's see, we have a question. Why can you access P in Inker even though Inker function is not formally, Inker function was formally called? That function was called right here, and it was passed the value of A, which was 4. That Inker was formally called. So what happened here, initially, Inker2 called here with P equal 3. And then right here, we had a function call calling Inker with P equal 4. So we did formally call both functions. So we had a function calling a function. Does that answer the question? This A right here, we look at Inker2 as this A right there. That 4 is the parameter to Inker. Therefore, P in Inker is 4 because it's this value being copied into here. If the B in Inker2 instead was B equals Inker2A, yes, that will become, it's called infinite recursion. A function that calls itself is called recursion. And if you have no way of terminating the loop, meaning it just calls itself repeatedly, then yes, that's an infinite loop that will actually crash your program eventually. We only have a limited stack space, and so you can only do it a limited number of times. I say a limited number of times, it's close on the lines of like 30,000 times, but still, to a computer, that means eventually it'll crash. But yeah, it's not a good idea to call without some termination condition. We're actually not going to cover recursion in CC8A. It's actually a fun thing. We use it a lot in 12. But yeah, it's a function that calls itself. It's called recursion. And it will make an infinite loop if you're not careful. Actually, I like that here. Let's see, that was caught in here. When we called Inker, that 4 was copied. And when we called Inker2, that 3 was what was copied up there. Okay. Any other questions on this before we move on? So remember, we're looking at the internal memory of Python. We're kind of like seeing how Python lays out memory, which is also a good way for you to figure out how a program works, especially on an exam. We're like, well, what is this thing doing? Well, the answer to that is draw it out.